Hi everybody, and welcome to this video tutorial on how to balance chemical equations. In this video, we're going to go over several examples of balancing chemical equations. But before we can get into that, there's something else we need to be able to do. So in order to balance chemical equations, you need to be able to identify how many of each element there are in a given compound. So we've done this at the beginning of the year, but I thought it would be good to do a review now. So let's look at some examples. Let's say we have Ca3N. So these little numbers down here, we call them subscripts. They tell us the number of each atom, okay? So this says that there are 3 Ca atoms, okay? Now, another thing we might get tripped up on is that the C and the A, we know they're together. They're one element. Calcium is one element. It's not like C and A are separate. And the reason I know that is because that A is lowercase, and elements always start with a capital letter. So that means the lowercase a needs to go with the C. So Ca is going to be one element, and we know there's going to be 3 atoms of that element. Now, for N here, we don't see any number. There's no number given. And when we have no number given, we know it's going to just be 1, okay, because we don't need to write down the ones. So that means there's going to be 1 nitrogen atom. Pretty simple. Let's make it slightly more complicated here. And here we see we have these parentheses. And when we have parentheses, just like in math class, we need to distribute any number outside that parentheses. So we need to distribute this 2 here and this 2 here. And again, I know O and H are separate elements because they both are capitalized. If I had something like OH, that would be 1 element. But since they're both capitalized, we know it's 2 elements. So let's look at this piece by piece. Mg, I know, is 1 element, right? That G is not capitalized. So Mg, there's no number, so it's 1 atom. Now, looking at that oxygen, when I distribute that 2 over, we know there's going to be 2 atoms of oxygen, and also for hydrogen, there's going to be 2 atoms. So whenever we have these parentheses, we just have to remember to distribute anything outside the parentheses. Now making this just slightly more complicated here. Here we're distributing again. We have that 3 outside the parentheses, so we're going to distribute it. Now looking at this piece by piece, this is aluminum, Al. The L is lowercase. That's not an I, it's an L. And so we know this is 1 element, and there's going to be 2 atoms. Okay. Now distributing that 3 into everything in that parentheses, we know S and O are separate elements because they both start with a capital. So here there's going to be 3 atoms of sulfur because we distributed the 3. But now for oxygen, or O, we have a little bit of a challenge here because we had to distribute that 3, but there was already 4 oxygen. So we need to multiply them together. So I have 3 times 4 is 12 atoms of oxygen. Okay? So we're always looking at those numbers, that subscript on that bottom right of our elements, and always remembering to distribute any numbers outside of the parentheses. Okay? All right, now that we have a pretty good grasp on that, let's look at balancing some equations. Here are a couple tips that are very helpful. The first step you're going to do is write the unbalanced equation. So the equation without any coefficients or those numbers in front. Then it's helpful to inventory the atoms in that reactants and products. And we'll talk about what that looks like. You're going to count the atoms before and after the reaction. And then you're going to balance the equation. Some strategies is that you want to balance elements left to right on the periodic table. So if you have any metals, make sure you balance them before you get to the nonmetals. If you have polyatomic ions that appear on both sides of the equations, you can use them, kind of pretend that they are 1 element together. Okay? And then also leaving hydrogen and oxygen to last. So let's look at this one here. So what I'm going to do is I'm going to make this inventory. Okay? So an inventory is just a list of how many of each element I have. So the elements I have are zinc, hydrogen, and chlorine. And now I'm going to count how many of each I have on both sides. So here on the left, I have 1 zinc. On the right, I also have 1 zinc. Now let's look at hydrogen. On the left, I have 1 hydrogen. The right, I have 2 hydrogens. Now let's look at chlorine. On the left, I have 1 chlorine. On the right, I have 2. Okay? So now I can see that my zinc is balanced, but my hydrogen and chlorine are not. So we're going to start, remember, we're going to leave hydrogen and oxygen to last. So we're going to start with chlorine. If I have 2 chlorines on the right and only 1 on the left, I need to find something that multiplies by 1 to give me 2. And that's going to be 2. So if I did 2 times 1 equals 2. So I'm going to put that 2 as a coefficient. That's the number before the molecule. Okay? So now this coefficient multiplies by both of these. So now instead of having 1 hydrogen, I have 2 hydrogens. And instead of having 1 chlorine, 1 times 2 is 2 chlorines. And now I can see that I'm actually done, right? Zinc is balanced, hydrogen is balanced, chlorine is balanced. We have the same number of atoms on both sides. And remember that this is because of that law of conservation of mass. We need to make sure that there's the same number of atoms on both sides of the equation because atoms are not going to be created or destroyed in a chemical reaction. They just rearrange. So this is the general procedure here. Let's make it a little more complicated with our second example here, where we have CH4 plus O2 yields CO2 plus H2O. Let's start with our list. So we have carbons, we have hydrogens, and we have oxygens. Now let's count how many we have. We have 1 carbon on the right, 1 carbon on the left, 4 hydrogen on the left. I'm sorry, I said that backwards. 2 hydrogen on the right. Now I have 2 oxygen on the left, and here I have 2 plus an extra 1, so this is going to be 3 oxygen on the right. Right, see, I have 2 from the CO2 plus 1 from the H2O, so I added that together. Okay, now I want to balance this out. So my carbon is already balanced. And so let's start by trying to balance our hydrogen. Okay, so we have 4 hydrogen on the right and only 4 on the left and only 2 on the right. Okay, and so I need to find something times 2 that will give me 4. And that's going to be 2. Okay, so that means right in front of my hydrogen, I'm going to put a 2. And now again, I have to distribute that. And now 2 times 2, this gives me 4 hydrogens now. But it also is going to change the oxygen. The oxygen was 1. 1 times 2 is 2. And then don't forget to add these 2 here. So now we have 4 oxygen. Okay, again, I distributed that 2. So there were 2 oxygen from the H2O and then 2 oxygen from the CO2. Add that together and I have 4 oxygen. Now my C is balanced, my H is balanced, but my O is not. So I have 4 on the right and only 2 on the left. So what can I multiply 2 by to get to 4? That's going to be 2. So I'm going to put a 2 in front of my O2. And 2 times 2 gives me 4. Okay, and now I'm all balanced. My balanced equation here is CH4 plus 2O2 yields CO2 plus 2H2O. Anything that you leave blank here, you can fill in with 1s, or you can just leave them blank and we'll know that they're 1s. Okay? All right, let's look at a third example here. Here we have KClO3 yields KCl plus O2. Let's make our list. We have potassium, chlorine, and oxygen. I have 1 potassium on each side. I have 1 chlorine on each side. I have 3 oxygens on the left and only 2 on the right. Okay, so now my potassium and chlorine are already balanced, so I'm really looking at balancing this oxygen. And I have 3 on the left and 2 on the right. And so I see this little problem here that there's not going to be anything times 2, any whole number times 2 that gives me 3. So sometimes when we want to do that, we want to look for this least common denominator type thing. So we're going to, it helps to find the multiple of these that is common, right? And so that is actually going to be 6. So we want to end up with both of these having 6 oxygen on both sides. So to get 2 into 6, I need to multiply it by 3. So I'm actually going to put a 3 right here in front of my oxygen. Okay, and 3O2, so 3 times 2 gives me 6. So now I have 6 oxygen on the right. Now on the left, I have 3 and I want to get to 6. So 3 times what gives me 6? It's going to be 2. So I put a 2 in front of the KClO3. So now this distributes to everything. So now we have 2 potassiums, we have 2 chlorines, and then 2 times 3 gives me 6 oxygen. So now my oxygen is balanced, but my K and my Cl are not. So I need to take another step here. So I have 2 potassiums on the left and I need 2 on the right, but I only have 1. Same thing with chlorine. I only have 1 on the right, but 2 on the left. So I want to multiply KCl by 2. So now I have 2K and 2Cl. And now this is balanced. So sometimes this happens where balancing one element sort of messes up the other one. Okay? And then you're going to have to take a couple steps back and forth. All right, let's look at a fourth example here. And we have C3H8 plus O2 yields CO2 plus H2O. Okay? Same process all over again. We're having a C, an H, and an O. Okay? Let's count how many of each. I have 3 carbon on the left, 1 on the right. 8 hydrogen on the left, 2 on the right. 2 oxygen on the left, 2 plus 1 gives me 3 oxygen on the right. Okay? All right, so let's look at trying to balance this. And remember, we said we're going to leave H and O for last. So let's start by balancing C. Okay, because none of these are balanced so far. We're going to start by balancing carbon. So I have 3 on the left and 1 on the right. 1 times what gives me 3? It's going to be 3. So let's put a 3 here in front of that C, and that changes my C to 3, but it also is going to change my oxygen here. Okay, so 3 times 2 gives me 6 now, 6 oxygen. Oh, plus 1 here. See, I can easily forget that. So don't make that same mistake. 3 times 2 is 6, plus add that oxygen over from the water, so that's 7. So now my carbon is balanced, but my hydrogen and my oxygen are not. Okay, let's try and balance this hydrogen because I think that might help us balance the oxygen. So here, I know this 2 and 7 is kind of hard for me to multiply in my head right away, but the 4, the 8 and the 2, I know I can multiply 2 by 4 to get to 8. So I'm going to do that first. Okay, so 2 times 4 equals 8, so I'm going to put a 2 right here. Okay, I'm sorry, I'm not going to put a 2, I'm going to put a 4, right? 4 times 2 is 8, so now this becomes 8 hydrogen. But again, it distributes over to the oxygen, so now we have to redo our oxygen again. So we have 4 oxygens from here, right? This 4 gives me 4 oxygens from the water, plus the 6 from over here, right? So 4 plus 6, right? 3 times 2 is 6. 4 times 1 is 4. That gives me 10. So I'm going to have 10 oxygens. So now my carbon is balanced, my hydrogen is balanced, but my oxygen is not. I have 10 on the right and only 2 on the left. So what can I multiply 2 by to get to 10? That's going to be a 5. So I can stick a 5 right here in front of oxygen. 5 times 2 gives me 10, and now I'm fully balanced. All right, Fantastic. You can see how this kind of involves a little back and forth, a little guess and check, right? And that's okay. Sometimes it's a little messy. Sometimes you'll have to go back and change elements multiple times, but that's all right. That's part of the process. Let's look at our last example here, example number 5. Fe2O3 plus CO gives me Fe plus CO2. So let's start with listing it. We have iron, carbon, and oxygen. Now I have 2 iron on the left, 1 on the right, 1 carbon on the left, 1 on the right, 3 oxygen on the left, and 2 on the right. Okay? And so this one is going to be a little more challenging. Oh, I should have put Fe instead of F. My apologies there. Okay? And so usually we want to start with our metal, but see how this metal is by itself? That's going to make it easy to balance, so actually I'm not going to start with that. I'm going to start with the oxygen. And so here we have the same idea here, this 3 and the 2. So when we have that 3 and a 2, we actually want to try and get them both to 6, okay? So if I have 2 oxygen on the right and I want to get it to 6, I'm going to put a 3 in front of it, right? Because 3 times 2 is 6. So now we have 3 times 2, this gives me 6. But don't forget, this spreads it out, right? So now we also have 3 times 1 is 3 carbons. Okay? And now 3 times 2 is 6. And we have, okay, so now we want to try and balance this carbon that we just messed up. Okay, so I have 3 carbons on the right, and now I only have 1 on the left. So before it was balanced, now it's not. We have to go back and balance that carbon. Okay, so let's do that now. So we have 1 carbon on the left. I want to make it 3, so I'm going to multiply that by 3. So I put the 3 in front of the CO, and that changes my C back to 3. So now this is balanced. Okay, but don't forget, it distributes. So for my oxygen here, I have 3 times 1 is 3, plus, don't forget this one over here. So 3 plus 3, this gives me 6. So now I have 6 oxygen. And just look at that. It just worked out perfectly here because now I have 6 on both sides. So sometimes when you have 2 and 3, the magic number you want to try and get is a 6. And the only thing left to balance here is my iron, which, like I said, is going to be pretty simple. I have 2 on the left and 1 on the right. And 1 times 2 is going to give me 2, so I'm going to put a 2 right in front of iron. Now we're fully balanced. Okay, so this is the general process for balancing equations. There's not like a really simple step-by-step, but what you want to do is you want to make a list of the elements you have and how many there are on each side of the arrow. Then you want to multiply them by different numbers to try and get these numbers the same on both sides. It's nice to start with your metals and then your carbons and then leave hydrogen and oxygen for the last. Okay? It does involve a little back and forth, so just takes practice. Keep on trying, and if you have questions, of course you can let me know. Thanks for watching, everybody. Have a great day.